In my video, the LotBot Base Project that's in my YouTube channel, LotBot Robotics, I was talking about the micro SD read-write adapter and its interface to the STM32. And I said in future videos that I would discuss this a little bit more in detail. So what I did is I took these components that have to do with the micro SD read-write adapter and the STM32, and I rebuilt it on another breadboard without all the wires leading to any of the other components. So what I'm going to do is use this breadboard to discuss this SD read-write module. Okay, I thought I would take this breadboard with these components and then this piece of paper, and then between the two of them show you the connections that I have to make between the components. Now, it just gets a little bit tricky here because the wires sometimes are not as obvious where they're going, so this piece of paper might help us there. I haven't really ever tried to use a piece of paper like this in one of these videos, but this ought to be an interesting experiment. Okay, right now the USB to serial adapter is connected to the Arduino IDE. Now the Arduino IDE in my case is the Mac. I've used it on a PC and a Raspberry Pi, but the cable coming into the adapter carries the voltage with it. So I've got that in red. And then, of course, the ground comes in that way also. And then data coming in or going out. I just drew that with one line, but anyway, the idea is it's the data. The adapter itself has a pin on it that supplies 5 volts for the rest of the circuit. So this 5 volts has to supply the voltage for the STM32. So we'll just draw a little line showing that connection. And then the ground also has to be the ground for the STM32. So now the STM32 has power that comes in from the whatever computer we're on for the Arduino IDE. Now, what happens is this is really how a program is loaded. It really comes down on the cable to the adapter, and it's on the transmitter and goes to the receiver pin of the STM32. Now, whenever the STM32 has data that has to go back to the serial display that's associated to the Arduino IDE, of course, it transmits that from the TX pin here back over to the RX pin here. So this is the communications. With this alone, we can develop a program on the Arduino IDE, bring it down, and run it on the STM32. Well, that's not exactly correct. What is correct is on the STM32, you have to take, because that's a serial connection, you have to take this little plug out and put it over here. The problem with this plug is you need a pair of pliers or something to hold it. So what I like to do is I buy these little jumpers with a little extension so I can do it by hand, and I could just simply put that on there. So now that jumper is in a position where I can download the code. So in order to download the code from the Arduino IDE, you move the jumper over here and you hit the little reset button right here, and you can feel it click. I don't know if you can hear it, but okay, that it clicks. And then you can compile the program or sketch, and you can download it, and it'll download over here to the STM32. Okay, this is all the wiring that's necessary for that. Now to test it, you can move the jumper over to these two pins, and you can reset it, and whatever is supposed to display on your serial display will display. Okay, now in order to bring in the micro SD reader over here, what I've done is I'm showing you the front of it and the back of it. The back of it mainly because the pins are identified, and I've got them identified over here also. Now these pins will be connecting to these pins over here. This is an SPI interface. Now there is two SPI interfaces for SPI1 on this board, and the problem with these pins over here, this side is a 5 volt tolerant, and this side is 3.3 mostly. And even though this SD reader has input voltage that allows 5 volts, the pins through a voltage regulator are really 3.3 volts. So it's better to use this SPI interface than this one over here. These characters in the front is the pin name. If you look at it on a pin layout, you'll see there's a P in front of these, but on the board itself, it would be like A4, 5, A6, A7. Okay, so what I want to do with this, I was going to show you one more thing. This reader for the micro SD card has a little spring load. It's pretty nice. If I want to take this out, I just push down and comes out. That's the micro SD card. But if you put it in, you see, it's like that, and you push down on it, and it stays down. And if you want it out again, you just push down on it, it comes up. So it has a little spring load in there. It's really nice. Okay, what I want to do now, in order to get the SD card working with the STM32, is I need to hook the voltage up to the 5 volts. So that would be, this would be hooked up to the voltage, and then the ground would have to be hooked up to the ground over here. So now the SD reader has voltage, and then what we have to do is the chip select has to be connected to the NSS. Okay, and then the serial clock has to be connected over here, and then the other two pins here are just data pins, but the MOSI has to be connected over here, and the MISO has to be connected over here. So that is a total connection now, so that you could run a program on the STM32 that you download and you build on the Arduino IDE that will put, if you had a micro SD card in here, it would write to the file or read from the file or whatever your code wants to do. Now, Of course, when you're doing this little jumper's over there and you're hitting the reset each time to download the code. When the unit is connected to the Arduino IDE computer, you notice that there are power lights on the adapter and the power lights on the STM32. Now, once you've loaded your code to the STM32 and it's permanent, you've got all the bugs worked out, you don't really need the adapter unless you come up with an update. So the cable is no longer needed there. However, if you don't have the cable, then you need to supply the power someplace else. So you can use any kind of a battery, a LiPo, or just a 9-volt. But then the boards on this breadboard require 5 volts. So you're going to have to change the 9 volt or the 11 volts with some sort of voltage regulator to the 5 volts and just connect it in. And then you'll be able to run this. Now, you might say that without a video, you don't see anything happening, but you could have a situation where you have a temperature sensor that's being read by the STM32 and recording the data on the card that you take out every once in a while and see what the temperature in a certain whatever is. However, if you do want to have a display on this and you don't want to be connected to the Arduino IDE computer, whatever it is, you could hook a display on here very similar to the one that I have in my LotBot Base project. After I'm finished with this video, I hope to produce a video using it also in this environment, maybe not with the SD card adapter, mainly because I want to emphasize what you have to do to use the display. The best way to test the use of the micro SD card adapter that's interfaced to the STM32 is to bring up the Arduino IDE. The display that I'm showing just shows an empty sketch template. Now, what I'd like to do is go over to the File and go to Examples, and then select the SD in the examples, and you'll see several sketches, and I want to pull up the read-write sketch. Okay, the read-write sketch is there. Expand it a little. Now, before I try to compile it, I've got to do two things. Number one, I'm going to plug in the USB cable to the USB adapter, serial adapter. Let's see, I need a, there it is. Then I've got to go over to the tools, and I've got to make sure that I've selected the board correctly, and of course I already have. And then I have to make sure the port is selected correctly, and it is. Okay, at this point, I could go ahead and compile the sketch, the read-write sketch. So that's what I'm going to do. It's compiling the sketch, and now it's erasing the memory on the STM32, and it loaded the sketch. So the sketch has been downloaded. At this point, I can bring up the serial display, and I can go over to the STM32, and I can move the jumper over to where I can test. I can hit the reset, and you see that it came out with some data that we'll look at when we look at the code. Let me just hit it again, you'll see it do this exact same thing, except this time it shows up another testing 1, 2, 3, 4, 1, 2, 3 rather, and you'll when we go through the code, you'll see why. And if I do it again, there's another one of those, and again, there's another one of those. Okay, that is the building of it. That's the testing of it. Now I'd like to just go through and show you how the code is working. Okay, now I'm going to look at the code. Let me just tell you what I have on the right side of the screen. What I did is I took the SD card out of the SD adapter and put it into a SD reader. Then I brought up the Finder on the Mac, which is display of files. And I looked for the files in the SD card, and there's one. It's called test.txt or test.txt. And I selected that, and I see 6 entries in that file. When I first demoed it, the first time it came up, there was 2 entries plus the entry that was put in by the code. And then I selected it 3 more times, the sketch, which gave me a total of 6 entries. That's why at the very beginning you saw 3 entries. That's mainly because I already had 2 files, 2 records on that file. Okay, now looking at the code, you'll see there's a big comment in the front, and the reason I have the picture of the Arduino MKR0 is that in the comment, the comments are a little confusing to me. In the comment, I have a chip select on pin 4. It says for the MKR0, and there certainly is a pin 4, but then it has these other pins, and I don't know what they're associated with, which Arduino, because certainly if I look at the pin 11 and the pin 12, you can see that's the I2C interface and not the SPI interface. And the MISO on the MKR0 is pin 10, and it's pin 12 over here. So these pins may be associated to some other Arduino board, but they're not specified in this code. So evidently there's a lot of hardware that you don't have to specify code. And even this CS pin 4, you'll see down below that I did not specify the CS pin that I'm using for the STM32, which was the A4 or PA4. So anyway, the only reason I brought this up was that these comments here may not necessarily specify the board you're talking about. At the beginning of the code, we include the SPI interface header file and the SD card adapter header file. We define a file, my file, and then set up the beginning for the serial interface at 9600 and make sure it's available. Then we put out on the serial display the initializing SD card. We initialize or begin the SD card interface. This begin actually has 4 parameters you could use. The first one is the chip select, which is 4, which is consistent with the 4 they specify up here. However, I did not change that when I ran my demo, and mine was my chip select is on PA4, which may be the same as this 4, but I don't really know of any way of associating it. So it checks to see if it's available. If it's not, then your initialization fails. Otherwise, your initialization was done. Then it opens the file, and notice that the file is text.txt, which is the file that I showed you earlier that had the records on them. Then it says, well, is my file available? If it is, it says it's writing to test.txt. That's on the serial interface that you saw earlier in the video. But the file it's writing is this testing 1, 2, 3, which you can see is one of the files up here. So it puts out the last file each time you write it, and that's why the number of it puts out the next record each time you write it. So that's why it keeps increasing by that one record. Then it closes the file and it writes out done. And you saw that in the previous part of the video. Otherwise, you'd get an error message. Then it goes to where it opens the file, and it simply goes through sequentially printing out the records in the file. And that's why you saw 3 records one time, and then 4 records the next, and 5 records the next, and 6 records on the next. Okay, the actual write of the record to the serial display is right here. Then it closes it, and unless there was an error, and that's it. So you notice there is nothing in the loop because the setup did all of the functions that were necessary to run that test, and that's why every time you hit the reset on the STM32, it reran this and put on a new record. Okay, that is the code. Now, if you can go through the other code that you saw when you went to the file and examples, the SD, and these other sketches. Well, that's the information I have about the SD card adapter and how it interfaces to the STM32 as I used it in my YouTube video, LotBot Base Project, as can be found on my YouTube channel, LotBot Robotics. Hope this helps somebody, and thanks for watching.